All right, so we're going to talk about 823 today, but we're going to kind of move through this first part pretty quickly because a lot of this was talked about in the videos last week. So in the videos last week, you saw how we could have a very simple complex plane that's based on our normal XY plane, where our imaginary numbers are the y-axis and our real number component is the x-axis. And we can pretty easily graph those points by just looking for the intersection of the two parts. So 3 plus 4i would be right 3, 1, 2, 3, and then up to 4i. So if you graph that point, you get this right here. Now what I want you to do is graph the remainder of these points that you see here. The four complex numbers represented by that would be 4 plus 3i, 4 minus 3i, negative 4 plus 3i, and negative 4 minus 3i, just to clear that up. And then make sure you recognize that this is two different numbers here. This is 5 and then negative 5. Okay, so go ahead and graph all, I don't know how many of those are, 16 points, and then come back, and I think it's actually 12. Come back and let's talk about what you're seeing. All right, so I'm hoping what you see is that those points all created a circle. So 0, 0, if you were to measure the distance from 0, 0 to any point on this graph, well, we know that the radius is going to be the same no matter where I draw it, right? So any of these lengths will be the same. So this and this and this and this are all the same length. Well, we know this one's 5, which means they all have to have a length of 5. So what that tells us, the distance from 0, if you remember that we have talked about that before, is the absolute value of a number. So when we want to find the absolute value of a complex number, we have to think in terms of like a circle. How far is that point from the center of the circle, or from 0, 0? So in order to do so, we're going to have to think in terms of another geometric figure that we're pretty familiar with. So I'm going to kind of walk you through this process here, and I want to start out by changing this to negative 4 plus 6i because it'll actually fit on our plane. Okay, so I want to graph the point negative 4 plus 6i. Just to make this a little bit easier on myself, I'm going to kind of extend those two parts of the graph that I need, so 6i, negative 4, just so I know where they intersect. So now I'm going to go ahead and graph the point negative 4 plus 6i, which will be right here. And what I'm trying to find is how far is that point from 0, 0. So if I were to draw a line that connects those, I'm looking for the distance here. That is going to be the absolute value, the length of that segment. So the distance of that between those 2 points will be the absolute value. Now, you probably already kind of see where we can head with this, especially since I gave you sort of a sneak peek that it was going to be triangles. If I take and create a right triangle here, I know a little bit of information about that right triangle. I know that the height is going to be 6, and I know that the length is going to be 4. Now, some of you might be upset that I'm not using I there. We're talking about the length of that segment, right? So it's 6 of I units long. So I'm just going to use 6 as my length there. Now to find the actual distance, I can use Pythagorean theorem. I mean, that's a pretty commonly used thing when we're talking about right triangles. So to find D, I can do D squared equals 6 squared plus 4 squared. And then I just solve that. D squared equals 36 plus 16. So that's 52. So D is the square root of 52, and we use the positive of it and not the negative because we're talking about a length, so it's distance. So the distance, or the absolute value, let's do that. Let's write this with the correct terminology here. The absolute value of negative 4 plus 6i is the square root of 52. Now, we could simplify the square root of 52 if possible, and it is. We can simplify it as 2 radical 13, and that's the absolute value of that number. So what I want you to do is to try C, see if you can do it, and then see if you can come up with a little bit of a quicker way to do this without having to graph it each time. All right, so hopefully you got the square root of 17 for part C, and then just simplifying the process, trying to come up with sort of a formula that we can use when asked to find the absolute value is you just take whatever your real component is and your imaginary's coefficient, and you square them and add them together, take the square root of it, and that's going to be your absolute value. Okay, so there'll be a few questions for you to try on Google Classroom, and then you'll have one more video left.